Hi everyone. In this video you'll be learning how to implement quicksort algorithm in Java. So quicksort algorithm is for sorting a list of elements and it was developed by Tony in 1960 and sometimes it is also called as partition exchange sort and it makes use of divide and conquer technique. So now imagine you have a list of array and now in order to start or in order to divide the given array into halves, we need to identify a position, and in order to do that we are making use of a value called as pivot value, and quicksort selects this pivot value in many ways, but here we simply choose the first item in the list, and some people will be using at the last or they might be taking at the middle, but here we will be simply using the first element in the list. And what is the role of pivot value? It is just to assist us where we need to perform split. Okay, and as you have studied in the quicksort algorithm, we have two functions, that is quicksort and one more is partition. So let us have a look on both the functions. Quicksort function will take an array as an input and it will decide where we have to partition, and that is achieved by one more function, that is partition. You can see we are having it on. We have partition function inside quicksort, and this function will help us to decide where we need to perform split. And once we know the position, then half of the array is called once and again another half is called once. So basically quicksort function is used to divide our array, and it is a recursive call. We will be calling this again and again, and then we will decide the position of every element. So once we understand the concept, you will understand this function in a better way. And what happens in partition? So in partition function, first we will assign a value. So here whatever we are having in our list, the first element in the list will be copied or it will be selected as a pivot value. So here you can see we are copying a of L, that is a of 0, whatever we have at the first element is copied into P, and then I am taking 2 pointers I and j. I is pointing to the first position and j is pointing to the last. Now according to the algorithm, it says we need to keep on incrementing I until we get a greater element than pivot, greater than or equal to pivot element. Similarly, we need to keep on decrementing j until we find a smaller element which is smaller or equal to pivot. And once we have that, then we can perform a swap. So we can perform a swap. And how long we can do like this? Until I is lesser than j. But once I is greater than j, then we have to perform swap with pivot element. So that's what our partition algorithm says. And now we'll see with an example. So here you can see we have a array with some elements, and now I'm selecting 54 as my pivot element. Now according to this, what we are doing, we will be finding the exact location of 54 in this given set of elements. Once we know that position, then whatever we have to the left, always it should be lesser, and to the right it will be greater, and there we will be performing a split operation. So now 54 is our first pivot element. Then once we have this, then what we have to do, I told you we are making use of 2 pointers. So that is I and j. Here we have it is named as left mark and right mark. So now I'll compare. So what we are doing, we are comparing 54 with 26 because my aim is to identify an element which is greater than 54 or a pivot element. Since 26 is smaller than 54, I will increment I because I told you we need to keep on incrementing I until we get a larger element than pivot. Similarly, we have to decrement j until we get a smaller element than our pivot. So here you can see in this example we started to compare. 26 was less, so we incremented I. Similarly, 20 is compared with 54. Since 20 is smaller, then we will swap these two elements. So here you can see 20 and 93 is getting swapped, and then we will continue further. Again we will go in search of an element which is greater than 54, and there our pointer will stop. Similarly, we will decrement j until we get a smaller element than pivot element. So here you can see it stops at 77 and 44, and again these two will be swapped, and again we are incrementing I and we are decrementing j because our aim is to identify a larger element and also a smaller element. Then we'll be swapping. So how long we can do like this until we have left, that is I less than j. Once I is greater than j, then we need. So now when we have elements like this, now in this case I am taking the first element, there is 7, as my pivot. So now we need to keep on comparing until we get a larger element, and we have to decrement from the right until we get a smaller element. Once we find these two, it has to be swapped, and again we will increment I and also we decrement j because our aim is to find the larger element and also smaller element. But once we cross, means once the pointers cross each other, then we have to perform swap with a pivot element, and that is the position where the pivot value was about to fit into. So then onwards we can call upon split operation, and now you can see 7 fitted into its exact position. Then we can have two parts of that array, that is left subarray and right subarray. Have a look on the program. So here you can see we have a main. So inside main we are just passing the array size, and it will be stored in a variable. And now we will decide, and with the help of random generator we are generating certain elements. Instead of giving ourselves, we are taking help of random generator. It will generate some numbers, and that will be passed into Quicksort. And here Quicksort is the class. So you can see here Quicksort is a class which we are using here. So Quicksort. So inside Quicksort I have two functions, that is one is partition and one more is sort. So in the textbook it was given as Quicksort. You can name it anyhow for your choice. Now we'll see what we're doing. So once we have the list of elements, I'm starting a clock because I need to know the efficiency of our algorithm. So I'm just calling system.nanotime. So this will be expressed in nanoseconds. And now I'm creating an object for Quicksort, and then I can access the function inside that particular class. Now with the help of m.sort, I am passing my array, and there's a pointer which points to the first position and also to the last position. Now once we have a call for sort, control flows to the function sort. Here you can see until low is less than high, we will be calling partition function. So partition, here inside sort we have one more call for partition. Now partition will call will be called by passing a, low and high, and we'll see what happens in partition. Now like I told you, whatever we have at the first position, that will be copied to p, that is the pivot value. And now I have taken a pointer I and j, means 2 pointers I and j, until I is less than j. What we do, we will be comparing a of I with the pivot, and it should be less than I should be less than I also. Then I'll be incrementing I, because our aim is to find a larger element than pivot. So that's what happening in this while loop. So this while loop is helping us to identify a larger value than the pivot value. Then I have one more while loop which will help us to identify the smaller value which is less than pivot. So we will be repeating this, and whenever I is less than j, we will perform a swap. Why we are doing this? Because ultimately after calling this function, once we identify the exact location of pivot element, all the elements to its left should be always smaller and to its right should be always greater. So that will be achieved here. So we are repeating this. So if I is less than j, we are swapping with these elements, and if not, once I is greater than j, then we will perform swap with pivot element, and we are getting j. So here we are passing a value, whatever you are written, that will be passed to this s. And now here is the position, like so. Here you can see now, if our array if I have, sorry, 1 second, if this is my, sorry for the technical disturbance, if this is my array, with the help of partition function, we will be knowing a split point, that is s. So once we know this s, then we will call 0 to s minus 1 as left subarray, and s plus 1 to high as right subarray, and we will be repeating this continuously until we finalize all the values. And now we'll run and check what we will get as output. So enter the size of the array. Now I will be giving it as 5. So you can see here randomly it has taken some numbers 7, 16, 5, 18 and 12, and the time taken to sort this array is 15822 nanoseconds, and you can see the elements are sorted. So at last you are supposed to plot a graph by taking different set of values, and you need to note on the time, and that has to be expressed on a graph. So you can take input size in your x-axis, and in your y-axis you can represent time, and you just plot the graph. So So that's all in Quicksort. Thank you.